Hello friends, today we are doing this question remove duplicate from sorted array. So what it is given in the question is we are provided with an integer num array which is sorted in non-decreasing order, which is ascending order. So we have to remove the duplicates from this array such that each unique element appear only once, like unique element should appear only once, and we have to remove all the duplicates from it. So this operations we need to perform in place. That means we don't have to use any new space. Instead, we have to utilize the array which is provided to us in the form of input. So one more point which is given here is like the relative order of the element should be kept the same. Then return the number of, so relative order of the element should be kept the same. What it means, like if we look this example now, so here 2 is coming after 1 and 3 is coming after 2. So in our final answer, the 3 should come after 2 and 1 should come after 0 and 2 should come after 1. So this relative order we need to preserve. And what we have to return? We have to return the size. For example, we have to return an element or integer of size which will have the size. Uh, So what we have to return is we have to return a value k such that the k element of the nums are unique element which do not contain any duplicate. So this is given in the question. Change the array num such that first k element of the num contain the unique element in an order they were present in num initially. So the same way like k we have to return such that the first k element of nums contain unique element and their relative order is preserved, and what is remain after k in the nums that is not that much important to us, so we have to return the k. And how our solution will be judged, so it will call for our function that we will implement. So it will return a value k, integer value k, and it will iterate from 0 to k, and it will assert for expected value and what we have returned. And if all the assertion are successful pass, then it will a solution will be accepted. So let's understand this problem using this example. So we are provided with nums which is 0, 0, 1, 1, 1, 2, 2, 3, 3, and 4. What we have to return, final answer is 0, 1, 2, 3, and 4. And after that, what are the remaining elements are there now? We don't have to give them the importance. So it can be anything. They can be 0 or they can be duplicates or anything. So we have to return the size of this solution array. So this will be the size which we will call as k. So what we can do here is like we can have a array in which we will store the elements which are unique. Like first we will store 0 and we will check for the uniqueness of the element. If it is already present in this array, then we will not put that element in this array. Otherwise, we will, if it is not present in this array, we will put that element in this array. So this can be the first approach, but what we are given in the question is like we have to do our perform a solution in place. Like we don't have to use this new array, we have to perform a solution in this nums array only. So here we can use two pointer approach. So how two pointer approach, like one pointer I will be iterating from 0 to n minus 1. Why n minus 1? Because that I will explain you just right now. And j will be a pointer that will act as a placeholder. So it will tell which place we are putting our next value. So we will point both j and I to the starting of the index. Now we will check for I and I plus 1. We will check for I and I plus 1. So we will check these two elements. So that is why we are implementing till n minus 1, because when will be at this index now, and it will, if we are implementing the solution, so it will check for I plus 1 that is not part of this array, so it will give us the runtime exception. So that is why we are iterating from 0 to n minus 1. So I will check for I and yeah, there will be two scenarios. One, if the element I and I plus 1 element are same, then we will increment ith value, and if I and I plus 1 are different, then first we will increment the jth value. We will replace the I plus 1 element with j element, and then we will increment I. So this will be a second approach. We will try run this. So yes, so starting from 0th index, I and j are at initial index 0. Now it will check for I and I plus 1, and both the values are same. So in first scenario, in first case, we will increment I. So I will be at second index, and uh, then it will again check I and I plus 1, so both are different. So what we will do then, in this case, first j will be incremented, so j will be pointing towards this. Then the value of j will be replaced by value at I plus 1, so it will be 1. And then I value will be incremented, so I will be here. Then again it will check for I and I plus 1, so both the values are same, so it will increment the value of I only. So I will be this. Then again it will check, so I and I plus 1 are same, so it will increment the value of I. And again, I and I plus 1, these value are different. So what we will do, first we will increment the value of j, and then we will replace the value of j with the value of I plus 1. So it will be 2. So it will be 2. Then I will be incremented, and it will be pointing to this next index. Then I and I plus 1 are same. Then I will be incremented. Then I and I plus 1, these value are different. So what again? J will be incremented to this value. Then j value will be replaced by I plus 1 value. So that is 3. Then I will be incremented. Then I and I plus 1 are same. So I will be incremented here. Then I and I plus 1 are different. So what it will do? It will increment the value of j, so j will be incremented. Then again j value will be replaced by I plus 1 value, so it will be 4, and I will be incremented. Now our loop terminates. So what here so what are the catch here? We have got our required solution. This is our required solution, so we need to return the value of j. So what we will return from here is j plus 1, because if we look for the solution now, it is still k. So if we are returning j, so k value will be j, and it is less than, so it is not including what is there in j. So we have to include j plus 1. So these all elements will be included up till j. So now this is the solution. So first we will implement this first pointer. So we will check if nums of I is not equals to nums of I plus 1. In that case, we will first increment the value of j and put the value of I plus 1. So, and then at the end of the loop, we will return j. So here I have used pre-increment operator with j. So first what it will do, it will first increase the value of j, then it will use that newly incremented value. So yes, so first we will run this code. Oh, sorry. As I have told, we have to return j plus 1, because it will not include the last value. Okay, now we will submit this. So it submits successfully. Now, what is the time complexity of this? So as we are iterating the complete array, uh, assume its size to be n. So its time complexity will be capital O of n, where n is the size of this array. So thank you for watching.